Hello and welcome to this new video. My name is MrGrey and I'll be taking you through some entertainment. In today's video we're going to talk about black holes. We're going to replace the sun with some of them, see how that affects our solar system, and we will talk about some crazy theory at the end of the video that could actually be real. So let's get started. What is a black hole? Most of you maybe know, but let's just do a quick explanation about what a black hole is. Black holes basically are stars. They were stars before they died. Now stars have different sizes, alright? And they don't all die the same. Our sun, for example, is a star, but it's not just gonna turn into a black hole when it dies because it doesn't have enough mass. First thing we need to know that the sun or stars generally, they don't burn. There is no burning. They are really hot, but that's not because they are burning. Because there is something that is happening that's called nuclear fusion, alright? Stars are made of gas. They are giant gas. And these gases, they just, do the nuclear fusion. I'm trying to make it as simple as possible. So the hydrogen turns into helium, which causes a lot of heat and makes these objects glow. They also have very huge mass. This is Stephenson, the largest star known. Now, when Stephenson dies, it will turn into a black hole. But how that happens? Like we said, huge mass means gravity, so there is a power, and this power is the gravity. Gases, they define gravity, they try to escape the gravity, they fly. They are not just like rocks or, let's say, iron or other hard materials, they just stick on the surface. Gases try to escape the gravity, and they do the nuclear fusion, but at some point, there will be no more gases, no more nuclear fusion. So the gravity will win. Let's imagine there are two powers. One is attracting and the other is pushing away. So when the nuclear fusion is over, the gravity will win for sure. In the case of our sun, it will turn into what's called a white dwarf. It will become just a small object, barely, giving any heat. But when we talk about huge stars, giants, like Stephenson. Now Stephenson's gravity will make the material concentrate in a very small dot, very small area, and turns it into a black hole. I'm really sorry, but this is as simple as I could explain it. Now, what do we know about black holes? We know that they're black, right? Let's add a black hole and take a look. We know that they are black. We know that they have a very strong gravity, all right? And we know that we can't see them. They're called black holes because we can't see them, because they're like, why can't we see them? Their gravity is so insane that even light cannot escape it. And when an object does not reflect light, we can't see it. How do we know that they exist? We can see the effect they make when they attract something. When they swallow something with that insane gravity, they make kind of glowing around it, not at the center. At the center, this black area, which we can see, this is the event horizon. All the rules of physics change here. This is going to be a very long YouTube video if I will explain everything. But basically, everything that crosses the event horizon cannot come back. There is no way they come back because of the insane gravity, and that includes light. So objects that cannot reflect light, we can't see. All right, now we know what black holes are. Now I added a sun, and universesandbox has already a few black holes. All right, let's add a black hole that has one solar mass. Take a look at that. Now we have the sun and a black hole that has the same mass as the sun, but it looks so small compared to it. That's because, let's imagine this is the sun after it turned into a black hole. Now we said, I know I said sun does not turn into a black hole. Our sun does not have enough gravity to turn into a black hole. Mass, the bigger the mass is, the bigger the gravity, the stronger the gravity is gonna be. But that's what I mean by the concentrated material. Imagine all of the gases are have just finished the nuclear fusion. The gravity wins, and the material then will be concentrated in this small dot. All right? This is why it looks so small. So we now know that the mass and the radius are two different things. Now let's put this black hole into our solar system and see what's that gonna do. Now I'll just replace the sun with a black hole that has the same mass. This is one solar mass, all right? It looks so small. We already saw these two objects next to each other, the sun and the black hole. But if we play the time, what is going to happen? Let's speed up time, really. All right, let's go super fast. And this is what's gonna happen. Literally nothing. Why? Because this black hole has the same gravity as the sun. It will keep our solar system in shape. It will keep everything in its place. The only real effect that is gonna happen is there is no more heat. Now this is universe sandbox. Black holes are not necessarily that cold. Here it shows me that this surface temperature of this black hole is minus 273 degrees. This is not necessarily real, okay? But the effect is gonna be like we simulated by shutting down the sun. We did a simulation in a previous video. We shut down the sun and we saw how that affected our solar system. We're not gonna see that again. If you like, you're gonna just click on the link on the upper right corner to see the video and what did that do to our solar system. Now there are more black holes here. Let's add a black hole that has 10,000 times the mass of the sun. Let's replace the sun with it. Look at that, it's still small. The radius is really small, but the gravity is 10,000 times the gravity of the sun. Let's hit the play button. Speed up time gently, so we can actually start seeing something. All right, that was a bit too fast. The closer these objects get to the black hole, the faster they become. Now all the planets near it have disappeared. It's tearing some objects apart. There are a lot of fragments. This is not a black hole we wish to have at the center of our solar system. Obviously, the solar system is dying. The result is gonna be really so clear. Look at Jupiter. Jupiter is somehow tried to orbit the black hole, if you saw that, but it just could not. Jupiter, our mighty guardian, could not escape the gravity of this beast. Let's jump to the monster level. Let's add a black hole that has 10 million solar mass, which means its gravity is gonna be 10 million times the gravity of our sun. Okay, now we can see something. Now that is big. Still, it's not as big as you might imagine it. Because, like we said, the mass is not like the radius, alright? Now we hit the play button. The first few seconds, nothing's happening. Let's speed up time again gently, just so, you know, the simulation is gonna be a bit faster. Okay. All of the planets, every single object in our solar system is heading one direction, and that is the heart of this beast. Look at that. Nothing is going to escape. Look at Neptune. Neptune is really far. Pluto is even further. Okay, let's see how are these guys going to react. Look at that. And in this case, there is nothing that's called, oh, I'm gonna try to orbit this black hole. No, my friend, don't even think about it. Nothing is going to orbit this giant monster. Everything will be swallowed, not even fragments. There will be no fragments even left. Look at that. Nothing left but the black hole. Now that is a black hole. Sir Stephen William Hawking was one of the most brilliant physicians that ever lived. Some of them consider him to be the second Albert Einstein. However, he suggests something that is really, really weird. He suggested, okay, the materials that are crossing the event horizon and going inside the black hole, they should be coming out somewhere else. And that's why he suggested that there is what's called white holes. How does a white hole function? It functions exactly the opposite way of a black hole. So black hole attracts material, it gravitates materials. White hole shoots the same materials out, so it's pushing things around it. There is no evidence, no proof, there are even no signs of the existence of white holes, but still this is something interesting to consider. And I would like to create a white hole. How to do that? I think, well, I know, to be honest, I just need to add a minus to the mass. So the mass is going to be negative. So things are no longer going to go inside, they will instead go outside. Okay, I didn't expect seeing things coming out of this black hole, but I am sure if something will come near it, it will just push it away. So how about we simulate that in our solar system? So I added the same black hole that has 10 million solar mass. We're just gonna name that a white hole, and we will make its mass a negative one. Let's hit the simulation and see what is that going to do to our solar system. Is Universe Sandbox going to cooperate? Yes, it is. Look. Look at the objects. They're just escaping. Look at that. Speed up time even more. Look, I didn't hide the trails, but nothing is orbiting nothing. Okay, and the negative gravity it just teared everything apart. Still, it killed our solar system. It didn't just push the objects away in peace. It just killed every single object in our solar system. Look at that. Trails are on. Nothing is orbiting nothing. Now, this is what would happen if all of a sudden a white hole will appear at the center of our solar system. However, what could actually happen if a white hole and a black hole that have exactly the same mass meet? Let's find out. All right, now the first one, we're gonna leave it as a black hole. All right, I added two black holes. They both have 10 million solar mass. It's really difficult to see because, like I said, we technically can't see. The second one, however, is gonna be the white hole, and we're gonna make it a minus. They both are exactly 0.5 AU far from each other. Now, I would like to take a look at this list. See, is the white hole going to push the black hole away and tear it apart, or is the black hole going to swallow the white hole? Knowing that they both have exactly the same gravity, but, you know, the opposite. Let's hit the play button. Speed up time gently, so we can start seeing something. Okay, black hole is moving. Is it gonna orbit? I don't think so. White hole is moving too. They definitely are doing something to each other, but I still have no idea what are they doing to each other. Speed up time even more. Even more. Oh dear. What did just happen? The black hole could not swallow the white hole, and the white hole just walked away. What did just happen? I have no idea, ladies and gentlemen. I have no idea. Okay, let's pause time. Did the white hole swallow the black hole? This cannot happen. Hell, it did. Now, I cannot explain that, but look, the mass of the white hole has doubled. Basically, it won. A white hole won. I don't know if that's logical. I have no idea if this is actually supposed to happen, but we saw it. They were just walking away from each other, and then the white hole was like, oh hell no. But the white hole has swallowed. It cannot swallow anything. It should be pushing materials out. Now, I have no idea if this actually is logical. I need your help, guys. Please write me in the comments section. Is this a glitch in Universe Sandbox, or if you guys use Universe Sandbox, I would like you to simulate that on your computer and tell me the result in the comments section. I don't know in this case if the white hole won or not, but yeah, we all saw what happened. This is weird. So this was the end of our today's video. Hope you guys enjoyed watching. Write me in the comments section if you want me to do specific simulations for future videos. I thank you for watching. Please don't forget to subscribe and like the video, and I will be seeing you guys in future videos.